So one way that we can show the bonding in a compound or an element is to show the outermost electrons, the bonding electrons, as it were, as dots or crosses. So they're generally called Lewis or electron dot diagrams. These are really useful because from this we can start working out the shapes of molecules. Before I show you molecules though, we can look at atoms, how we draw those, and how we show ionic compounds, because we have used electronegativity so far to work out that not everything's a covalent bond. There are ionic bonds as well. And we can use these dot diagrams to show ionic compounds too. So the first thing is I've got a few atoms here from the periodic table. And we're keeping them as atoms, even though some of these would almost certainly form ions. We leave them as the atoms because they only become the ions when they react with something else. Okay? And I'll show you how I've built them. For something like magnesium that I know becomes magnesium 2+, I just put the two dots together. I get the 2 from its electron configuration, 282. It's that last number, that's all that I'm worried about. I don't worry about other electrons, just bonding electrons. It has 2 bonding electrons. What's the other word for bonding electrons? Starts with V. Valence, cool. So I'm looking at the valence shell or valence electrons only, because they're the ones that might be involved in bonding. It's that shell that is. Oxygen is 2, 6, so there should be 6 dots around there. Well, you notice I've got 2 that are single and 4 that are paired up. So 2 pairs, 2 singles. That's important because that'll help me to show how oxygen goes together, okay, with other things. We'll get to that later. Chlorine, 287, so I've got 7 dots around it. So let's just go through these 2 quickly, nitrogen and carbon, to see what they would look like, and how I would build these on a bit of paper or when I'm getting started. So first of all I need to know where it is on the periodic table so I can find its atomic number. Nitrogen is number 7. Alright, so that means its electron configuration is what? 2, 5. Excellent. So, how many electrons am I going to put around the outside of this for my Lewis dot diagram? 5. So not the whole 7, just those 5. And the way that we do it is we start wherever we want and we go clockwise. We think of it having 4 places to put electrons and then we start pairing them up. Okay? It's not technically true. You should pair up the first 2 and then go singly around like that. But I don't want to teach you that way yet. That's a good way to do it when you get more complicated ones. So with 5, we're going to start here. Go 1, 2, 3, 4, 5. You can use crosses if you find it quicker and easier, which normally you will on a bit of paper. Crosses are much, much easier. Okay, so that's the Lewis electron dot diagram for nitrogen as an atom. It's not what it is as an element, because that would be N2 and would need to start forming some bonds between the atoms. Alright, trying to fill up this valence shell to get it up to 8. Carbon. What number is carbon on the periodic table? 6. So what's its electron configuration going to be? 2, 4. Excellent. So how many electrons are it's involved in bonding?
4.
Good. So its valence shell only has 4, so we're only going to draw 4, not 6. Again, going clockwise. You notice I haven't put them in the middle, and that's because there's room for another one to go there. There's room for another one to go there, and so on, so they can pair up. The reason for that is it just is more organised. That's almost like a jigsaw puzzle. We start to form things into there. Okay? I'll take away those dotted line ones because they will confuse later, so I'll get rid of them. But that's why they're not just together. Alright? So that's how we do an atom. Not too bad. What about ionic compounds? Now I've done 2 there, and I'm going to show you what I've done with this. You'll notice that magnesium up here, I've got the 2 next to each other. Because this has got chlorines, they're probably going to be one on either side to show this. So I've just changed it from this to this. You're allowed to move the electrons around if you want to. It doesn't make them wrong. Okay? It's just a representation, so just move the electrons to make it work more easily. Then I just stick the chlorines in, one either side, vote is chlorine with the 7. You'll notice I've used crosses and dots to show the difference of where the electrons come from. It's actually irrelevant, okay? It's irrelevant because actually all of those electrons are involved in making this an Mg2 plus and these Cl minuses. Actually, in reality, all of those electrons are associated with the chlorine, not with the magnesium at all. So what would be more correct to show would be this. A negative ion there, it's got one too many electrons. Mg2 plus with no electrons around it because it's lost both of those valence electrons. And then another one on the other side. Oops, put the negative in the wrong place. Square brackets is just holding it all together, as it were. That's all that represents. So that would be more correct, but this is what they'd be after an NCEA. Okay, this one here is what they're after an NCEA if they ask for magnesium chloride. You'll notice with calcium, I probably should start with magnesium to keep it the same, but calcium and magnesium are the same for Lewis dot diagrams because calcium is 2, 8, 8, 2, so it's still just the 2. You'll notice in this one I've just actually stuck them together. I've made a mistake there, sorry. I've put too many electrons in here. With oxygen, it's got 6 in its valence shell. Okay, so oxygen itself is, and I'll use crosses just for speed, this. Okay, so you can see how I've done it there. But what we're trying to do is to pair them up at the end. So once I've stuck that in place, I've got these two sitting here and here. Well, that's not really, you're trying to get all the electrons paired up because that's how they're stable. So I'm just going to move this one into this place here, or I could have moved that one down to the bottom. It's my choice, and both are correct, by the way, to do this. What that is saying is that the oxygen has now got all of those electrons in that gap between them. This is the ionic bond. This represents the ionic bond. Okay, that is our ionic bond. So the ionic bond, if it was a sharing of electrons, would be those 4 electrons. So electron dot diagrams for ionic compounds, basically it's just like sticking things together. They're the easy ones to do. Okay, in the next video, the next bit of teaching, I'm going to show you how to do it with molecular elements, so your elements that are more than one atom, and compounds, so things like methane, water, that sort of thing. And they are the ones that we focus on more in this topic. This is more just an introduction to Lewis dot diagrams. Before I stop that, are there any questions that you want to ask now? Okay.